some calculations you have to be able to do as a pilot. Discussion page here. Weight and balance calculations. Wham! Weight times arm equals moment. You have been doing that on your weight and balance calculations. That's how our little sheet is laid out. Weight times arm equals moment. You got that. And you have been doing total moment divided by total weight. That equals the center of gravity. So nothing new there. But a silly way to remember that is mom's overweight. So not an insult against our dearly beloved mothers, but moms means moments, the total moments divided by the weights. So you can see, lay it out in division. Mom is overweight here. Mom's overweight. Okay. Try a top hat question here for you. Determine the center of gravity point of the following weights. So remember, for this one, we're going to have to find total moments and find total weight. All right, really got to hustle. Weight times arm equals moment. Total moments, total weight. All right, so if you got approximately 55.6, you are correct on that. So you should have gotten approximately 45 pounds for the total weight, and all of your moments should have been approximately 2,500 added together. And mom's overweight. Okay, now FA will probably give you a test question for a weight shift or weight change problem. On your commercial check ride, don't be alarmed if the examiner gives you a weight change, like a passenger comes along or a passenger moves a seat. Don't be surprised. So our basic concept here is we're shifting a small portion of the weight and we're shifting at a certain distance. So we can easily use a formula of the amount that we are shifting over the total weight of the aircraft. So it's kind of little weight over big weight. And we set that equal to our center of gravity change. Delta CG, that's a change of center of gravity. It's a small number. And how far did we shift that weight? So that's our formula. We'll know 3 of those numbers, and we're going to solve for the unknown number on it. So in our example here, we have an aircraft that's loaded with a ramp weight of 3,650 pounds. And our current center of gravity is at 94 inches. How much baggage has to be moved from rear baggage at station 180 to the forward baggage at station 40 in order to move the CG to station 92. So that's a total of 2 inches. So that's our sample problem here to work on. Setting up our formula, little weight over big weight equals little distance over big distance. So little weight, how much weight are we moving? We don't know. Big weight, 3650 equals delta CG, right? 94 inches to 92. That's a 2-inch change. And we're moving it from station 180 to station 40. That's a difference of 140. So there's your setup right there. And that's going to be our top hat question here. So go ahead and get started on that. So when you're taking your time here, once you got the formula set up, it's just cross multiply, solve for x. All right, let's see how you did. Looks like a lot of you got the right answer there. So approximately 52.2.1. All right. So quick peek at it. Here's our formula set up there. We don't know how much weight we're moving, but we know we're going to current CG is at 94, move it to 92. So that combines to get us our 2 inches of delta CG. At 180 is where the weight is. We're moving it to station 40. That gives us the 140 there. All right, so there's your solution. Okay. Now, one more is a weight change problem. It's a similar formula. There's a small difference to it. Weight change. Passenger could get on or off. Add bags, take off bags. Burn fuel in flight or add fuel on the ground. Okay, we're changing the weight of the aircraft. So our change of weight, which is going to be a small number, is over the new total weight. Okay, that's a little change here. It's still little weight over big weight, but now make sure we get the new total weight in here. Okay. Delta CG, that's the change of center of gravity. And then we have the distance between the weight location, the weight change location, and the old center of gravity. So just applying this to a formula here, or an example, given a 6,000 pound aircraft flying with a center of gravity of 92.4, you have 25 gallons of fuel are consumed from the tank during flight. What's the new center of gravity? All right, so obviously we got our 25 pounds of fuel, 6 pounds per gallon. I'm sorry, I said that wrong. 25 gallons of fuel times 6 pounds per gallon. So it's going to give us, what, 150 pound change. So that's our small weight, 150 pounds, divided by the new weight. Okay. Our new weight is 150 pounds less, 5,850. We're going to set that equal to the delta center of gravity. We don't know how far the center of gravity moves yet. And our current CG is 92.4. That's the old CG. Subtract off where the weight is changing, 75.0. So just doing our math real quick. Difference of 17.4. Do that right? Okay, yeah, 17.4. So there's your setup for this problem. Okay. I'm going to jump ahead here. Because when we come up with the solution to this problem, all we get is how far did the center of gravity change? Well, what is the new center of gravity? I want to introduce the teeter-totter concept to you. Think of our weight and balance. Our center of gravity location is a fulcrum on the teeter-totter here. So we got the nose here on the left side and the tail's the right side. We are looking at the center of gravity position at 92.4, and we are removing fuel during flight from station 75. That's ahead of the CG. So that means the nose moment is becoming less, or you're becoming more tail heavy. So in this case, we have to shift our CG rearward by 0.446 inches. So you got to think about it. Which way do I apply my change of center of gravity? Am I going tail heavy or nose heavy? And now I know how to readjust it.